Hi, my name is Mark Hahn. I'm a security solutions architect for Qualys. I come to this by way of development background. This is...
Hi, I'm Ted Hahn. I'm his son. I'm also an independent site reliability engineer. I help startups get started with the whole cloud thing. I'm also an ex-Google SRE, so I've been doing this for a while. Did anybody come to my workshop yesterday? Anyone? Nope. Okay. Totally different crowd. Great. I can reuse all the same jokes then.
Yeah. If you want to follow along with the presentation, you can click on that link. That goes to our website, and you can see the slides.
Sweet.
So a lot of people get into cyber threat analysis through many different career paths. A lot of them end up at cyber threat intelligence kind of through this path. Like, who in the room sort of recognizes themselves in these boxes? Okay, most people, well, a bunch of hands. Actually, about half, I'd say, so far. This is kind of my point of view, from more of a developer point of view. How many people kind of recognize this as their career path? Fewer hands. Okay. Yeah. So that's going to make this talk weird, because coming at it at a different viewpoint from this.
Yeah.
So, I think about things as a developer, as an architect. So I think more about application security than I do about like SOC stuff and vulnerability management and so forth. So we took a different approach on this. So my thought in doing this, when I wrote it up, like, hey, I want to learn about this stuff. So, I'm just going to fire up a bunch of open CTI tools, log into Shodan, read some dark webs, and like, that's it, man. This is going to be great stuff.
I didn't disabuse him of this notion. Like, I kind of thought this would be that simple too.
Yeah. And then next thing you know, scratching the record. That's not how it worked out. Totally different adventure than the one that I set out on. And there's a disconnect. Kind of my point of view is a disconnect on this, in that your CTI people tend to work SOC operations. They're looking at files and indication of compromises, and they're looking at ways that attackers are using the MITRE attack framework, and this is all laid out for them. My problem is the cloud. I manage an AWS organization. I really don't care about the infrastructure, because honestly, it's for demo purposes. All the infrastructure is disposable. It's also, in many cases, built to be vulnerable in weird ways, because it shows off what our product can do for detection.
And so much of your infrastructure today is disposable, right? You're not thinking about these in the same old ways, and you're not really worried about persistent threats on your Kubernetes machines that are re-imaged every 2 weeks. Like, the tooling has not caught up in that way.
Right. And the other thing I'm thinking about is the cloud control plane, which operates very differently from your internal infrastructure. Number one, you've got this shared responsibility layer with your clients, with your cloud provider, and so you take on a different set of roles than you do with your infrastructure, where you're building everything up. And honestly, people haven't talked a lot about what account compromise and cloud attacks look like. Yeah. What we're looking for is an attack matrix, but for the cloud control plane, your AWS API, your Azure API, your Google, your GCP API. Yeah. And if you do research, if you just kind of Google for what are cloud attacks, Aquasec is one of the kind of the premier cloud security vendors. This is their top 10 list. This is how they order it. Number one, everything on the left side here is not a cloud attack. Yeah. It's a traditional infrastructure attack. Yeah. So, like, figuring this stuff out is a pain.
These are the old attacks, but they've just slapped cloud on them because your infrastructure is in the cloud. But they are not the cloud attacks. They are infrastructure attacks that you happen to still see in the cloud. Yeah.
Denial of service attack. Do you think AWS is a attacker going to prevent you from using the AWS API by flooding it with a DDoS attack? Ain't happening. No. Just not happening. And if it does, like, the world has bigger problems. Security misconfiguration. Yes, it can be a cloud problem, but it is not the cloud problem. And it's also not really an attack. This is my stupidity. It's not an attacker doing stuff. Cloud malware injection attacks. Well, this is actually just malware injection attacks on your cloud infrastructure.
Yeah.
Cookie poisoning, not a thing here. That's browser stuff. Insecure APIs. I'm sure there are bugs in the Azure API. I'm sure we'll find them.
But they're not your problem.
Exactly.
They're not something that you're going to worry about.
Cloud crypto mining. Somebody abusing your infrastructure, not abusing the cloud. Like, there's nothing cloud about this. They did get like 4 right and sort of 4.5. Account hijacking. That's what I worry about. Like, is somebody using my accounts that shouldn't? Yeah. User account compromise. Is there somebody pretending to be one of my users that shouldn't be? Yeah. Kind of the same things, but account hijacking is like they took over an administrator account in my organization versus just a user one.
Yeah.
Insider threats, yeah. I mean, equally applies in the cloud.
More than equally, it's even bigger of a problem because all of your infrastructure is in the cloud, and all of the it's much easier when everything's centralized into this cloud control plane for an insider threat to escalate itself much more quickly.
Right.
And touch much more.
Right. Side channel attacks. So yes, a legitimate cloud attack, but whose responsibility is it?
Yeah.
Not mine.
Not mine.
Yeah, it's AWS's. They should be the one looking for this stuff. Session hijacking, legit attack in the cloud that I should be looking for.
Yeah.
So, what I'm finding is that, like, it's desert out there in terms of thinking about how do I want to protect my cloud infrastructure from cloud-specific attacks.
Yeah.
So, where does that leave us? This is the wrong expertise. I'm a developer, not a SOC guy. I'm taking the wrong approach, right? And it's not easy to find the prior art. So what do? Back to basics. So what is cybersecurity threat intelligence? What are our basics? How do we work up from first steps to where we want to get to? And then how do we approach it? And then what can we do this is the TTPs of what should I be doing? What are the things I should be doing to find the TTPs of my foe, my enemy? So number one, take the definition of cybersecurity intelligence, and you're going to be looking at data. You're going to be doing this. Yeah. What are the things? You're going to everything around this. The actionable insights, like the word actionable is like pops right out. Every definition that you look at is going to say actionable.
Because there's plenty of false positives and there's plenty of non-actionable ones, and the whole point is not to overwhelm yourself.
Yeah.
Because you can jump at every little pretend threat and you will just tire yourself out.
Yeah. But, whoops. My definition is slightly different because I'm a programmer. Yeah. So, when you're running a security operations center, you have a set of processes that you go through. Mm-hmm. Cyber threat intelligence is about debugging those processes. Yeah. What more do I need to look for? If you've already got an alert set up, that's not CTI, that's just operations. Yeah. So what we're doing is debugging those security operational processes. It's out of band, it requires a human, and it's a feedback loop back into those operational processes when you do find something actionable. So this is what I started to look at was this approach. I read a lot of background reading on just what is CTI. This, I think, is recommended. The Psychology of Intelligence Analysis. How many people have heard of this book? Okay. Read it. If you're going to go into CTI, read this first. It's not that hard, but it's also, it's 1999 by the CIA. Like, this is how their intelligence analysts work it. It's great. Yeah. I recommend that. The DoD Intelligence Community Directive, but basically that is the, what do they call it? Authority to act. Yeah. From the Director of National Intelligence, DYI. Worth reading. It's fairly quick. It's kind of boilerplate, but it's worth reading. Splunk has a good paper that I think does a good job of kind of laying out the basics. I'm not a big fan of their peak, but they do explain Squirrel and Tahiti, which are structured methodologies that help you think about cyber threat intelligence. And so reading till you get to that point and stopping is probably worthwhile. The other 10 pages of that document are not worth. Tradecraft primer, also good. I also recommend, just for anybody in doing agile development, building new things, searching out new solutions for problems that have been around, the U.S. Army Field Manual Reconnaissance and Security Operations really talks about how do you learn new stuff in the field when.
I recommend reading it as a kid. Great read if you're about 12 years old.
So, but yeah, no.
Seriously, give it to your kids.
Yeah. Okay. So what as a CTI analyst do you do, right? So number one, you need a framework for your hypothesis, not just tools, but you need to know how to think about CTI. You need to make sure that you're not getting caught up in cognitive biases. We assume that certain things are going to happen, and you need to make sure that isn't coloring the way that you look at the data. Because there's a crap ton of data, and it can scare the living daylights out of you, or you can look at it objectively. And so you need a way of working on that. You need to learn how to basically ask questions. So the biggest thing I learned here probably is it's hypothesis driven. Ask yourself a question, figure out if you can look at the data to prove or disprove that hypothesis. And so we'll go through some of that here, and we'll show you some of the tools that we use. Yeah, there actually will be tech in this. Like, it is DIY. Actually, they misspelled it in the
schedule. Yes, we are DYI, or do yourself in, apparently.
Yeah. 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 But we will get to tech here, and we'll talk about how we came up with some hypotheses and how we tested those.
Yeah.
And we'll talk more about like how, I think as an industry, we need to think more about this in particular, because I think too many people are getting surprised by the fact that they have attackers that are not attacking their infrastructure, but their cloud control plane.
And it's a constant, it is a race. It is a constant arms race, and you need to be developing in this, field. You need to be not just using tools that come off the shelf, but actively developing and thinking about your own tools and your own threats, because not everything is going to be, an off-the-shelf attack.
Yeah, exactly. So what are our tools? So again, we're starting at basics. So focus in on the CloudTrail logs, which tends to be the vast majority of data that you can get. Like, yeah, there are certain things that the infrastructure you build is going to tell you, but the vast majority of it in your CloudTrail logs, your infrastructure logs on Azure, same. And the tools that we use are JQ. Anybody not familiar with JQ? Is this the first time you've heard of JQ? A bunch of people.
Okay. No.
Explain it.
Go look up JQ. JQ is not JSON query, but it is a tool for querying JSON. And it provides a simple language to basically just parse over lots of JSON. It allows you to slice and dice the data. So if you've used JSON lines, such as your CloudTrail logs, it allows you to say, find me all of the rows in this CloudTrail log that have this user ID associated with them. It allows you to then reconstruct and parse and process JSON. So if you've got, you want to construct an object that from each object you want to aggregate or gather all of those objects and create an array that's based on, here is the list of all of the users that showed up. JQ is a great little domain-specific language for JSON parsing, and it should be in everybody's toolbook.
JSON's a command line tool, so you got to have the files on your local PC to run it.
Well,
Athena is an AWS tool, and we started in Athena because it's kind of the most accessible. You can do the same thing in Azure with Cosmos DB. You can do it in Google with Bigtable.
BigQuery. It's roughly the same thing.
Yeah. So we asked ourselves a couple of questions here before we got started and tried to figure out how do we find the answers to these questions. Has someone logged into my accounts? I have an organization of about 84 different AWS accounts. Has anybody logged into those accounts?
Yeah.
Has somebody created and used access keys? So how many people here use AWS on a regular basis? Okay, fewer. So AWS has two ways you can get access. One is to use what's called access keys, where you basically create a stored secret and an identity and a pointer to that secret.
The whole user's system.
Yeah.
And it's designed from a traditional user account perspective, right? It's the original way to get access to AWS, way back in the day. You would create a user, and that user, you would give that user permissions, and you would get a secret that was that user's effectively password.
It's a long-lived password.
Yeah, long-lived password. You would store it on your developer machine, and every time you went out to AWS, you transmitted that password to them.
Yeah.
That worked, but it has many problems, the most notable of which is it's long-lived, right? So AWS has more or less discouraged using user accounts at all. If you try to create a user account in the AWS console, it will spend 3 screens talking you out of it. So you should probably not be doing that anymore. And that's why we're asking the question, did anybody try to do this? Yeah, because it's important. It's important that you, in most organizations, it should now be policy, you don't create user accounts, and then you have exceptions.
So, and then what are the attack matrices? And that's sort of an open question here. But so how do we start answering some of these questions? So again, CloudTrail logs. What we did here was to download some CloudTrail logs, and we will quickly show you how this works.
Yeah. Demo time. Pray to the gods for us.
Yes. Okay. So first thing that we're going to do, all of our CloudTrail logs are up in the cloud. We need to get them locally so we can play with them on a command line tool.
And you can see,
You can't, the pointer's too light.
Okay.
But
well, you can see the structure of the CloudTrail logs. It says AWS logs, here is the organization ID, and here is the account, or the region at which it happened, the date, time, and then the account again. This second account is an account as opposed to the organization account.
Yeah, so 2 different numbers. That's the org we belong to. This is the account inside that organized.
Yeah. And then it's got the time again because, of course, it does.
And then, they're all just gzipped files of a bunch of JSON messages.
Yeah, JSON lines.
Right. So step 1 is like, what does this look like? So
what does it do? What can you do with this?
Yeah. There we go. So what we're going to do is run this command with GNU unzip, and we're just going to pick a selection of files. So we're picking stuff that happened today, because that's today's date, at UTC time at 15 and 16 past the hour. So at 3 and 4 past the hour, 3 o'clock, 4 o'clock in the afternoon, UTC time. All those files we're unzipping. Then we're asking JQ, look inside that list, pull out the records, show me just the event source inside there. So there's a big, long object that's, hey, this is the event that happened. This is what's in the log. But I just want to look at the event source. Where's this stuff coming from? And then little bashism to basically say, these are how many events happened and the number. So yeah.
So
first brush with our seam. So then let's go back to the presentation. If I can find PowerPoint, come on, there we go.
There you go.
And so dealing with CloudTrail logs. They sprawl. As you can see, that was 1 day's worth of CloudTrail logs.
It wasn't 1 day's, that was 2 hours worth of CloudTrail logs, right? They create them by the dozen. They create a new one for each of many different operations every single minute. It sucks, but it's what you work with. I
mean, if you can concatenate them all together, like we did, you get the full result. But they create for operational reasons. They create a file about every 2 minutes, some faster than that. But the idea is they want to give you the CloudTrail logs sooner rather than later. So they're not batching them up, they're giving them to you. Each file contains anywhere between 1 to 20 different events. And they don't index easily. And of course, if you want to, this is the size of what we're dealing with. So about 20 gigabytes of data in CloudTrail logs for a day. Oh no, actually, I'm sorry. This is a quarter.
That's a
This
quarter,
is
yeah.
3 months. This is from January through March.
Yeah.
Yeah.
Well, and it's not a whole lot in terms of data processing. You can do this on your local machine if you so wish.
Yeah.
But it's also a pain to download all of those logs if you're just going to query it, and then you'd got to go resync them live all the time. Yeah. Nobody wants to do that.
But it's also 2.5 million objects, so
Yeah.
2.5 million files.
That's a lot.
So very, very small files. This sprawl makes life difficult. It also makes it difficult to work with like seam tools and so forth, right?
Yeah.
One of the reasons I chose Athena was that it actually kind of was built around this use case.
Yeah.
Not well, but it was.
Yeah.
But trying to get these into a seam tool like Graylog, like part of my thought was I was going to fire up Graylog and I was just going to pump this data into Graylog and let it do the indexing and do the searching. How many people know what Graylog is? Good. So yeah, it's a seam tool. It's built to do this sort of thing. Getting these logs after the fact into Graylog is a month worth of effort.
Yeah. It's just not feasible, right? Yeah. And you want to have the seam set up well in advance, but if the seam doesn't do exactly what you want it to do, you want the alternate pathway, and you're not going to set up a second seam because you can't pump those real-time events back into your seam.
How many already have, of the dozen people who have a seam up, how many are putting their CloudTrail logs into their seam? Okay, most of you. I mean, I think if you've got a seam, it becomes easier to do that than not. But starting from scratch, like, how long did it take you to implement a seam? 1 week? A month? Yeah, I hear laughing over here. Yeah, it's not. Yeah,
not easy.
Not easy.
No.
So, and I had a full-time job. Plus, I was trying to pack to move to the other side of the country. Yeah, this was not going to happen. So, hypothesis one, like going back here. I've got a dormant account. So the way that let me go back here. So no, I'll come to it later. But I am a lead for a team of about 30 SSAs. Yeah. We give each of them a couple of accounts, and then there's some dormant ones, some SSAs who've left. So my question was, is one of these dormant accounts, one of these SSA accounts that I'm not using anymore, still being used? Like, should I be worried about this? Is one of my post SSAs still logging in and crypto mining on my dime? Maybe.
It's a real threat.
Honestly, for some of them that have left, yeah, that would be what I would expect. So how do we do this? Like, well, number one, we're probably looking for IAM keys. We're looking for signs of access.
Yeah.
So what would that look like? I mean, my first check was, well, thank goodness there are no IAM keys in this account. And my security tool told me that there's only a few IAM keys inside of all of my 30 SSA accounts. So I'm like, okay, or 84 SSA accounts for reasons.
Right.
But let's see, where do we have this next demo set up? So what I did, so this is what CloudTrail looks like in AWS. It's pulling stuff in and saving it in an S3 bucket. This is all of those files as seen through the AWS console UI. And then some more JQ here to see, hey, look, can we see what's going on with keys?
Yeah.
So hold on a second. We'll switch to demo here.
Yes.
That's this
one.
window.
Yep.
So what we did.
3 or 4.
Yeah. There we go. First of all, we started looking at, hey, what does this need to be bigger? Can you guys read this? Bigger? Okay. So these are the events coming out. Interestingly, down there at the bottom, there are 2 AWS sign-in events. Okay, so somebody is signing in here. Let's see what we can do. So the first thing we did was, what do those events look like? So this is, in its gory detail, CloudTrail record.
Yeah. JQ also nicely prints your JSON and makes it so much easier to work with. That's maybe my number one use.
So it's got a bunch of different information in here. Some of the fields we've already been talking about. Here's the event version. the user identity, the event source is the key thing down there.
An event name, which is the AWS event, right? You've got these IAM actions, and that's what you do.
Yeah. So this is somebody logging into the console. This is actually, we did this today just to see. So one of the things you're going to do is, like, what action would my attacker be doing? How do I know what that looks like in AWS? I'm going to go do that in AWS, copy down my CloudTrail logs, and look for the event that looks promising. Yeah. That's what we did here. So, just basic.
Yeah. Test your hypothesis by breaking it yourself.
Yeah.
Do like, if you've got a SIEM, you should probably be, breaking policy every so often, just so that you know that it will alert you when you break policy.
Yeah. And then the last thing we did was, okay, so what was the ARN of the user that logged in, right? So with JQ, we're able to pull that out. Lo and behold, it's me logging in. That's the test. Yep. So now I can go look for these in bigger sources. Now JQ is just going to choke. Yeah. Plus, I don't think I want to download all of these logs to my local machine. Like, they're already in.
Kind of a pain.
Yeah, yeah. But we did some other things that we did along this line was, I'm not going the wrong direction. I'm going the wrong direction. Yeah. Yes. Was look for, through a series of actions, where can we find the action of create access key? Yeah. Like, this is what we're looking for. Somebody's created an access key. This is what it looks like in JQ. I found it in JQ for a test run. Yeah. So, like, now we're beginning to understand what's going on.
Right. Now we understand the structure of the log.
Yeah. So, this is great for JQ here. We're down at the raw, the assembly bits of the thing. We can use it to find specific items. We can do it for trial and error. And we don't pay cost on it. Because every time you run a theta, they bill you. Yeah. So,
cents at a time, but it adds up quick.
Yeah. But again, JQ isn't going to do 20 gigabytes of data easily for you. Yeah. So, hence, I'll use this, the CloudTrail. So the first thing that you do when you get to Athena for CloudTrail, which is kind of a known pattern, is AWS wants to sell you CloudTrail Lake, which is better than Athena for doing this stuff. Oh my God.
Because AWS wants to sell you a service to manage the service to manage your service.
Yeah.
And they've created the whole problem to begin with. But
yes. We'll sell you coffee and then we'll sell you beer to calm you down after you've had too much coffee. Yeah. Starbucks is missing that business model, by the way. Maybe I'll patent it. So this is what those JSON structures look like in Athena. AWS will help you create this thing. So that's very cool. So in Athena, you create this, and the first thing you do is try to query, just a sample set. Yeah. In JQ, we basically get the results as soon as we press the enter key. In Athena, it takes us 6.5 seconds to give me a sample. And it gets even worse if I want a sample from a particular account. So this query ran for much longer than 20 seconds. I canceled out of this query because at some point I was afraid I was going to break it. It actually probably would have ran for about 1.5 minutes here. Yeah. That's a long time to process, and it was processing probably a couple hundred megabytes of data because of the trying to filter on a particular account. Yep. So that's just problematic. Like, if you're doing, I just learned something, I want to query to answer this question, what does it look like if I tweak it a little bit, right? You want to be able to kind of just do that back and forth. And right, with jQuery,
the repetition, the development cycle has got to be short. Yeah. And it's not short.
With JQ on a small set of data, it goes as fast as I can type the commands. So I'm right in my OODA loop, right? So I can think, ask the question, get a result, think, ask a question, get a result. If I have to wait 30 or 40 seconds or 90 seconds between queries, I'm sorry, squirrels, beer, Coca-Cola, something. I'm off getting chips. But you can improve this by doing Athena partitioning. What if partitioning in Athena does is say, okay, I know that the data for this index is in this file. But Athena doesn't know that until you tell it. Even though AWS built the thing and it knows, like they built it this way, but you got to go tell it this is the way it's built. However, doing this partitioning, this is an art. It's not a science. It's an art. And the CloudTrail logs are broken up by account, region, and then days, which, natural sorts of ways. But it also can be broken up by service, but the files aren't, but the logs are. Yeah. So we can only partition off of what's in the file name. And so it turns out we have 16 regions in AWS. We're collecting logs on all of them. I happen to have 84 accounts, and at a time period of 90 days. Do that multiplication, you come out with about 120,000 partitions that I've got to pump into Athena. And if you just start doing this the straightforward way, every API call is about 0.8 seconds. So 0.8 seconds times 120,000 partitions is multiple days to try and do this. Yeah. So this is painful. It took me a full day to figure out how I saved myself 3 or 4 days. And I don't think I did it right. There's a way to do batch partitions, and I just discovered that you can run these things, you can launch them in the background in your shell, as long as you don't launch too many of them at a time. And you can increase the rate by about a factor of 15 or 20, which was enough that I could just set the computer to go do this and then go pack a bunch of boxes to shove in my pod to get ready for moving. But this is painful. And I'm sure seams do this for you, but you still have to give the seam some information. Yeah. That's the beauty of using a seam. Yeah. So in the end, I ended up with 152,000. That's what's in there now because there's a couple of extra days and some other stuff. Now that query that would have taken multiple minutes is down to 30 seconds. That's a win, but
still a little long.
Yeah. But we're getting there. But I'm doing this over the entire 3 months of data, not just on a few hours out of a day, right? And across multiple accounts, across the entire worldwide, not just one. Now we can do this for the entire quarter for a day. It's 36 seconds. So what we're seeing here is that as we scale up, the query time doesn't scale linearly. What Athena is doing in the background is doing multiple batched systems, multiple threads to go do this, and it's optimizing in the background. So accessing a little bit of data, there's a ton of overhead, but once you pay that overhead price, larger queries don't take as long. Yeah. And so if we do this over the entire set of accounts, all 84 accounts across all regions across the first quarter of the year, the first 3 months, I can run that query in 4 minutes, which is not bad. Yeah. So you run the query, you do the work to figure out what it needs to look like on a smaller subset of data in your OODA loop, and then you go run the query big time across your entire swath of data. So then, again, now that's all the tech back to who's created access keys in my accounts. That's what I want to know, right? So I came up out of the entire set of accounts, the 84 accounts across I came up with 4 instances of access keys being created. This is good news. There are 30 some odd SSAs who are all logging into their AWS accounts. Only 4 of these guys are making mistakes. So somebody read the documentation. Yeah. We'll dig into these. So I lettered them A, B, C, D, right? And I did some more research digging into each one, and this is exactly what you're going to do in computer threat intelligence. You found a little bit of something. Does it make sense? Does it not make sense? What's going on here? So on January, this is the one legitimate use case. On January 6th, one of my SSAs provided another SSA account to his AWS account to look at a project that he'd done. So they were collaborating, and this was a good use. Well,
better than awful use.
Better than awful use.
You should have created a role that could be assumed by the other account's role, but we can excuse that.
Right. Yeah. This was the shortest path for them. I'm like, okay. And it showed up because we're creating access keys. It showed up in our vulnerability tool, so it's okay with that. So, it's a demo of how to detect this stuff. The second one is a new SSA that got hired in February just using whatever he'd learned at his previous job, did not read the manual, stopped at step 1, did his own thing, right? So training opportunity here. On March 24th, a different SSA started with the company, and SSA number 1 taught him how to do this without reading the documentation that I'd wrote. So more training opportunity. Last one was that new SSA who'd been taught by the other guy doing something on a different project. So what I have here is, a sprawling problem if I don't catch it now, but I caught it.
Yeah.
But what I did not find here, and I still need to keep searching for, is there anybody else in weird places using my account? So let's see, I want to back up to, let's see what this looks like in Athena.
Yeah.
We've got a couple of queries in Athena we can run live. Any questions?
Yeah.
So we can start with this sample here, which is basically the, just show me kind of what, did we screw this up?
You clicked on it again, and when you click on it again, it reloads the query.
Oh.
Yeah.
Um,
Oh, no, I think it reloads the query, and the query had changed. Yeah. Yeah.
Okay. Yeah, it's hard to see here. Where's recent queries? There?
No, at the top. Yeah.
Oh, recent queries. Thank you. All we wanted to do was select star and limit 10. Yeah, this one right here. So, so this is the equivalent of just printing out a few records in the database. And so we're using SQL-like queries, which is kind of nice. Like people have learned SQL. And this is just showing a random selection of 10 queries and then stopping in the back end. Comes
It
back.
gives you the data shape and some idea of what it will look like.
Yeah. This is looking at basically event sources. So again, this is the question of where is my data coming from, and what, beginning to pick apart the data.
Yeah.
But again, we're going to wait like I think 27 seconds for this one to come back.
Yeah, roughly 30 seconds.
Yeah.
So.
But we're just counting up, what are the event sources and how many records of each.
These event sources, if you really want to get into the technical details, like AWS, each of their hosted services can be an event source. Each of them has essentially its own, starting point into AWS. So.
And I think as was mentioned by this guy, there are some useful features, like your queries are all saved. In fact, to set up Athena, you set up an S3 bucket that's your output, and in that output is going to be saved a metadata file and an output file.
Yeah.
So this data, the query is saved in a metadata file, and the output is saved in a separate output CSV file. Yeah. So all that record is there in an S3 bucket for me to go back and look at. Yeah. Like I'll never forget anything. Yeah. Of course, it's going to create one of those files for every query I run. So if I'm doing, run a query, get a result, run a query, like, that S3 bucket's filled up, and guess what? It's partitioned by days. So like, if I have to remember on what day that I run this query, was it in the morning or afternoon? Because I got to go, yeah. So, but it's all there. Like it's
all
that's
available.
Useful.
Yeah.
Yeah.
Don't rerun the query for this one.
Yeah. This was our console login. So this was essentially, and now I've limited it to 1 day.
Yeah.
If I did the whole thing, it would probably be 4 or 5 minutes. But for 1 day, for St. Patrick's Day, March 17th. Oh, no, sorry. What console login? So this is this across all of my accounts, but for a single day.
Yeah.
Useful to look in. So this is answering the question, how many console logins, right? So this stuff can be useful. One of the things that we did with this was look at what are the IP addresses of these logins?
Yeah.
And so, we only had 3 results here. So here's the source IP address.
Yep.
Hold on 1 second. So let's take these and plug them into.
So if you're not familiar with MaxMind, it's a IP geolocation database. It's sort of the IP geolocation database, and if you need that data, go to them. Oh, of course.
Let's refresh this page and then
Yeah. There we go.
Yeah. So reasonable. This is out of Beaverton, Oregon. So this is probably Ziply fiber. Is that industrial or you think residential?
Probably residential, actually.
Yeah.
Ziply is
Yeah.
it's what I used to have in Kirkland, actually.
Okay. So the good news is Joe is an SSA who lives in Portland. So it's probably Joe.
Yeah.
And then the other address was address in Redmond, probably me, actually.
So, there you go.
But this gives you the ability to kind of, bring some stuff together and look at data.
And slice and dice.
Slice and dice. So yeah, it's a bit of a hodgepodge of tools, and it would be better.
No, it's do it yourself.
Yeah.
Or do yourself in.
Yeah. Yeah, it's a lot of work. I mean, I think just using a seam for SOC is a lot of work, right?
Yeah.
Yep. Okay. So, but you need good hypotheses. You need to ask good questions. And this is where I think as an industry, we're kind of like not thinking about the cloud the way we should. Maybe you could educate me. Maybe I've been searching in all the wrong places for what are cloud attacks and what do I need to go look for in my logs.
Yeah. But this is the toolkit you can do it ad hoc and figure it out for yourself.
Yeah.
Cool.
So thank you. So you guys who are familiar with seams, does this look familiar or am I barking up the wrong tree? OpenSearch, Elasticsearch might be a better tool.
Well,
Yeah. Yeah.
yeah.
Okay. Okay. So that may be true. Yeah. Any other thoughts? Yeah.
Does the similar process translate to other cloud platforms?
Yes. Yeah.
So the same exact data is available in your GCP account with BigQuery, and it's more or less the same experience. It's all in a cloud bucket, and you can download it to your local machine. You can JQ over it, or you can run it through BigQuery and just get it.
I think AWS and GCP do a good job of saying these are our cloud logs.
Yeah.
When you deal with Microsoft, they're like, oh, here's the tool you use to query your cloud logs.
Yeah.
Right. So actually trying to get your hands on the cloud logs in raw form is harder, just because they want to push you through their experience. They have cloud log analytics.
Yeah.
They push you to this tool, and so if you really wanted to just download off the storage account where the stuff is stored, they don't really document that well.
Harder to do.
Yeah. But yeah, it's the same experience, same exact thing. Yeah.
It sounds like these are issues that occur when you are serving people at scale. As somebody that doesn't have much enterprise experience and has only been like implementing SIEM locally and in a small environment, like how soon or at what level, at what point am I generating so many logs that I would have to use the program?
I think that is a good question. So you're starting with a smaller base. Like I started with, I started with 84 accounts to begin with. That's pretty big.
Yeah.
Like we have lots of cloud customers. Lots of them are in we have a dev, test, and prod account and an infrastructure account, 4 or 5 accounts, right?
If you've just got one AWS account, you can probably S3 sync your CloudTrail logs down and be fine.
When it starts getting painful is when you're running up against it, right? If it works for you, it works for you.
Yeah.
I would have engineered this differently if I'd had more time. Like they told me in February, and by beginning of April, I had to have a working SIEM for worldwide cloud operations functionally in my spare time, without pissing off my wife because I wasn't talking to her for weeks on end.
You did that anyway.
I did that anyway, but yes. So really, when it gets painful, like it's time to find a new tool.
Yeah.
When your SIEM tool is charging you per record ingestion and you're paying too much money for it, it's time to get a new tool.
Yeah.
I mean, yeah. And it can be fun. Like there were parts of this that were painful, but a lot of it in the end was kind of fun.
It was an interesting exploration.
The painful part.
Athena is useful for more than just this. Like the ability to query over a set of JSON-like logs in your AWS S3 account is like there's a reason they have a whole product devoted to it. It's not just for CloudTrail.
The other thing I'd say, it's helpful to have somebody you can ask questions of.
Yeah.
So I think he was setting up for doing his own talk. We were supposed to collaborate on this. The 2 or 3 times we talked about this, like I came away with much better ideas than I did on my own.
Yeah.
So collaboration is useful.
Backup.
Yeah.
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 Cool.
You mentioned earlier about, particularly with working with the cloud security, that you're constantly trying to develop tools you have in order to keep up.
Yeah.
Are there any other examples that you'd like to share about tools that you've built for security?
Other tools that we built for cloud security solutions.
And then
Well, I mean, we sell a cloud security tool.
Yeah.
It's the technical term for it is a cloud security posture management, CSPM. That's what the industry calls for it. There are also, everybody's sort of like, now if you've got a CSPM, you need other tools around it to differentiate yourselves. Gartner now calls that a CNAPP, Cloud Native Application Protection Platform, CNAPP. So there's a whole source of tools there. Aquasec, Qualys, Wiz. Where's my badge? They're probably half them on the badge. Or,
Yes, look at the back.
Yeah. So Rapid7, who's one of the sponsors, sells a CSPM. So CSPM is the configuration piece, the where am I making mistakes. As for tools around the what are attackers doing to my piece, I don't know that we've got cloud-focused SIEMs. I think we have infrastructure-focused SIEMs, things that we'll suck in your Windows event logs, we'll suck into your Linux systemd logs, right?
As a smaller practitioner, like the sorts of tools that I have built, so I've done exactly the same sort of thing with Postgres. So I will suck down the RDS logs from Postgres and look for connection attempts to see if there is any machines in our cluster or pods in our Kubernetes cluster that are trying to connect to Postgres and failing. Like we should never have a connection failure. We should never have a login failure within our production environment. And I built the tooling to check that. Only run it once a quarter because it never finds anything, but I know it would find anything because I've, gone and failed logins to make certain it works.
Yeah.
That I've done the same, like that sort of thinking can be applied to a bunch of other things. I've found that sort of logging in application web logs. So basically every application is going to be a little different in terms of what queries you might find and what outputs it's going to have in your logs. But this process of looking over the JQ output from a day's worth and figuring out what I might be looking for, and then sending it off to Athena or a MapReduce to actually run it across the whole set, is pretty common. So like another place I've done this is, we had a application vulnerability, and if you set a certain kind of header, you would appear to be coming from, and this is just the classic proxy. You set the proxy header and pretend that you're coming from inside. Like we checked to make certain that nothing had the proxy header that wasn't actually proxied through that. And easy enough to do when you have the logs there, but it's something you'll need to do on an ad hoc basis when you discover that vulnerability.
Yeah. I mean, what you do is you take these questions and then you operationalize them, right? So I run this once a quarter. I run this once a time period.
Yeah.
Something that I check for on a regular basis.
Yeah.
So, and that's what I'll do with this is start looking for who's creating access keys, because that's the wrong way to do it. Like there's better approaches for everything.
Yep.
Same thing, and so those CSPM tools tell you where do you have mistakes in your infrastructure? Where do you have access keys, right? And they're kind of focused, like, I mean, they're focused on what people have known for a while. It takes a while for
Yeah.
like attacker tactics to percolate into don't have these settings so you can, or set things this way to prevent those tactics from succeeding on your infrastructure, to building it into a tool so that now you can automatically check with the tool, right? That's what the CSPM is for. There's a long lead cycle there for that.
Yeah.
So, there's still, like, if you go to the Center for Internet Security, CIS, AWS Foundations benchmark that tells you all the proper settings for your AWS stuff, and it's not told you by AWS. Like, AWS will be happy to tell you how to run your infrastructure. The guys at CIS are practitioners like you and I and him. They've been burned by it, so they're going to give you, I think, more straightforward advice. And that's what a lot of CSPM tools built from, is that CIS. Anyhow, it takes a while for people to get burned, to get it in the next revision of that document, for it to get into a product update, for you to have, a tool that you're paying a company money for to help you protect your environment. Like that period's at least 2 years long.
Yeah.
So you need to be able to think about some of these things, run your own queries so that you can do your own thing.
Yeah.
So.
Cool.
Okay. Well, we're kind of at time, 10 minutes. We'll give you 10
Yeah.
minutes between things, unless anybody else. Come on up front
Yeah,
if you got
perfect.
questions. Thank you.
Yeah. Thank you very much.